so 4 to the power of x equals 50. How do we solve that one? We have to use logs. Why do we have to use logs? Not because there's no whole power of 4 that equals 50, but because x is an exponent. Okay, and if x is an exponent, then you have to solve this. And you have to solve it using logs. Okay, that's going to be the easiest thing for you to remember. So, get your formula sheet out, rearrange this. This rearranges to be x equals log to the base 4 of 50. How do I put that into my calculator? Yep, so it'll be log of 50 over the log of 4. What, log 4 over log 50? The base one, whatever the base is, has to be on the bottom. Okay, that's the key thing. And since this is the base here, that one, base. That's what I'm trying to say. This is log to the base 4 of 50, because over here, this 4 is the base. You're happy with that? Chuck it into your calculator, you should get an answer of 2.821. 2.821, what sounds of it? 2.82. Yep. That is 2.82. Right. Next one then. How are we going to do the next one? Same thing. So y is log of 300 to the base 7. Yep. And so from there, it's log of 300 divided by the log of 7. And your calculator, that one there will be 2.9, 2.93. Happy with those ones? Okay, so the next one then. This is the first one where it starts to get a little bit trickier. How do we solve this one? Same way. Okay, so this now, this whole thing, x plus 3 is equal to the log base 2 of 102. Okay? Now you know what log to the base 2 of 102 is, because that's just a number, isn't it? That is a number that is log of 102 divided by the log of 2. So that number is 6.67. Happy? So therefore, x plus 3 happens to be equal to the 6.67. So what does x equal? Yeah, it now is like forming a linear equation where x plus 3 equals 6.6. And how do you solve that linear equation? You just take 3 off both sides. Probably don't need to calculate for minusing 3 off that answer, but there you go. Happy with that? So x equals 6.67 minus 3, which is 3.67. Yeah? That's the same with the next one, eh? This 3x minus 5 happens to be log 200 to the base 4. Okay, so I chuck that number into my calculator. That is 3.8. So now what we've got is 3x minus 5 equals 3.8219, etc., etc., etc. So how do I solve that equation? Plus 5 to both sides. So we've got 3x equals 3.8219 plus 5. So that's just the same as 8 0.8219. Now what do? Divide by 3 now. Because I've just used my calculator, I don't press on. On it. No, that is irritating, but it is wrong. Plus 5 equals, divide by 3 equals 2.94. So x, divide both sides by 3, and therefore x is 2.941. Okay? And leave that answer, don't do 8.8219 because you've rounded too early. So leave that answer in your calculator. Okay? Questions with that one? So in the exercise, there are some of those sort of questions that you guys will be able to have a go at now. But this last one's quite a tricky one. Okay, so how would we do this last one? You don't have to, but you can do that, yeah. That's one way of doing it. Definitely. So what Billy's saying is, in fact, you probably all should know that 4, that's the same as 2 squared, isn't it? So rather than writing down 4, you can write down 2 squared, which is 4 to the power of x, times 2 to the power of x is 206. We'll do that one in a minute. That one there, we'll do that later. So this now is 2 to the power of 2 to the power of x. How do you do that? Yeah, you times these exponents. That's that indices stuff you did at the start of this topic. So this is now 2 to the power of 2x times 2 to the power of x is 256. And 256 is a 2 to the power of button, so it makes it a bit easier. So that was because I chose it a bit easier. When we've got two numbers that are our bases, what do we do to our indices? You got x squared times x to the power of 3. What do? You add them. That's 2. What's 2x plus x? 3x. So 2 to the power of 3x equals 256. Can you see that? And from there, that's when you do your logs. So now 3x equals log to the base 2 of 256. That gives you an answer of 8. So 3x equals 8. So x equals 8 over 3. Okay? Happy with that? Seen, yeah, correct some of those? Right, so I'll pause this. So the other way of doing this one would be to go, well, Billy chose to convert this 4 into 2 squared, but you can't always do that. If that was 4 and 5, it's going to be too hard for you to do that. What you could do is you could say, this is 4 times 2 all to the power of x. Okay, so in other words, if I gave you a times b to the power of 3, if I gave you a times b to the power of 3, what would my answer be? A cubed, b cubed. Is this what you're talking about, Tim? So a cubed, b cubed. In other words, what I've done is I've raised that a to the power of x, and I've raised that b to the power of x as well. What's 4 times 2? So now this becomes 8 to the power of x is 256. And so x is therefore log to the base 8 of 256. Okay, you check those answers and I think that'll give you an answer of 8 over 3. Log 256.
I always forget.
Divided by log.
I always forget about this.
Yeah,
I'm always like, right, fucking there.
So tried some of those ones. Now this is the applications of these sort of questions now. Okay. I feel like everyone here has a pretty good understanding about how to solve one of those simple exponential equations. Is that fair? Yep. So now we make that harder is we bring in a whole bunch of words. Okay, and these are real life applications. There are a lot of real life applications with these type of questions, because anything that is exponential in growth or anything that is exponential in decay, you have to solve using logs. So in other words, I've got $50,000 in my KiwiSaver. My fund is generating 5% growth. If I don't put any more money in, it makes it an easy exponential question. When will I have $1 million? Okay, that's how much money I'll need for my retirement. I plan on living a wee while and plan on living a pretty decent life. Right?
How long do you plan to live?
How long do I plan on being retired?
What are you planning on? What are you planning on there, Jess? So yeah,
Oh,
I think
this is not
past
good,
20
so it's not right. So how do we solve that?
Right.
Right.
I'm tapping out.
How do we solve that one? Is there anything like we've been doing so far? Yes, but no, wait. Because there is no equation in. So what's the first thing we need to do? Make the equation. Yep. So we need to find an expression or an equation that models how much money is in my bank account, in my KiwiSaver. So how do we figure out how much is in my KiwiSaver? 50,000. 50,000 is my starting point. So 50,000 is actually going to be in my equation. $50,000 times what? Not 0.05, because that would be a decay.
1.05.
Yeah, 1.05. If I asked you to find out how much money would be in my bank account after 1 year, what would you do? You would find 5% and then add on that number 8. So you would find 5% and you would add it on to the total. That's where you get the 1.05 from. Okay. If it was a 15% growth, that would be 1.15. Okay. If it was a 1% growth, it would be 1.01. All right. If it was a 2.5% growth, it would be 1.025. So that is how much money will be in after 1 year, because there's an imaginary 1 up here. After 2 years, I would change that 1 to a 3 years. I'd change that 1 to a. So in T years, I would change that to T. And that is my expression now. Okay. And so now what I'm asking you to do is to solve where K is 1 million. This is too many zeros. That many. Okay. There's my equation. Does that look tricky? Looks tricky probably because the 1,000, the 50,000. How would I solve that? Not minus, because this is 50 grand times this. So how do I undo that times? Yeah. So I would divide both sides by 50 grand. What is 1 million? What is 1 million divided by 50 grand? So this is 20. This part here is 20. What does that 20 mean? It means my investment has to be 20 times bigger. Okay. So now what I'm trying to solve is that question there. Can I do that? Logs. Log to the base 1.02 of 20. How do I solve that? 20 calculator. Log 20 divided by log of 1.05. Okay, so I would need to work for 61 years to get that $1 million.